bonus question. This is a 2-in-1 question where you have given that root 2 equals a. Evaluate these questions giving your answer in terms of a. Now looking at question 1, you have root 10 over root 5, and question 2 you have 8 over root 2. The question could come in another form where you have given that the square root of 2 is 1.4. Evaluate these questions giving your answer in decimal. Now, same process you apply in solving this question is that you apply in solving it when you're given the square root of 2 as decimal. Let's take the first question. Square root of 10 over square root of 5. Square root of 10 over square root of 5. Now, you can remember the part of the series where we have division of sorts. You can actually go and say 5 here 1, 5 here 2. Here you have square root of 2 over square root of 1. You can say square root of 2 over, square root of 1 is 1. So you have this as 1. Anything over 1 is that same thing. Like saying 2 over 1 is 2. Therefore, root 2 over 1 is root 2. Since the question says express in terms of a and root 2 is a, therefore, root 2 is a and a is our answer. This can work, but it's best to use this when you're working with OBJ. This is not standard when you're working in theory, where you have to show you're working. This method is not standard. A similar but standard or acceptable method of solving this kind of question is, let's say you have root 10 over root 5. In sorts, when it's either division or multiplication, when you have it in this case, you can either give them their separate square roots or link them by one square root, provided they're either linked by division or multiplication. And also, they must be in the same roots. Like both of them are in square roots. It's not that one is in cube root and the other in square root. No, they have to be either both in square root, cube root, or other roots, but they should be in the same root. Next you do, if they are in the same root, is you have it equals, you have a big square root, then you have 10 over 5. It's allowed that you take this root 10 over 5, give them their separate root. That's root 10 gets a separate root like this, and root 5 gets a separate root like this. Meaning you can either do it this way or do it this way. Now it's allowed to have it like this, and we can therefore work on the fraction. So we have this as equals, 5 can go in 10, 5 in 5, 1, 5 in 10, 2. So we have this as our big root, that's 2 over 1. This is equals square root, 2 divided by 1 is 2. So we have it as square root of 2, similar to this. And like the question says, it wants our answer in terms of a. And we know root 2 is a, so we have this as a. Our answer is a. So whichever method you prefer, any of these two or the next to be taught, you can apply in solving this question. But it should be noted that the first method is not accepted in theory questions. You can either apply this particular one, the second one, or the third one, which is also standard and can be applied or used to solve the question. But whichever of the other two methods you prefer, which is this particular one and the next one, you can apply it in a theory question where you have to show your working. But in objective or in OBJ questions where your workings is not required, you can apply the first method, provided you really understand the first method. Third technique, we have root 10 over root 5. We know in 10 you can find 5 times 2. Now you should try as much as possible to make sure, like in this case, since you can find 5 in 10 or 10 has 5 as a factor, make sure this 10 reflects 5. That's the essence of having a question like this. So we have root 10, also same thing as root 2 times 5 over. That is 2 times 5 is 10. So root 10 can also be equals to root 2 times 5. Now we can have over, the denominator is root 5. This is equals to, we go back to the numerator where you can give them their separate square roots. The 2 can get a separate square root, same as the 5 will get this separate square root, because they are linked by multiplication. If they are linked by addition, you can't do it. So you have root 2 times root 5 over root 5. Now at this point you can say root 5 cancels root 5, you'll be left with root 2. That means dividing root 10 by root 5, you get root 2. Now that you have your answer as root 2, this is not your final answer. Going back to the question, it says given that root 2 equals a, evaluate these questions giving your answer in terms of a. That means since root 2 is a, our answer, which is root 2, is a. Root 2, which is our answer, is a. Therefore, the answer to this question, root 10 divided by root 5, or root 10 over root 5, is a. Because root 10 over root 5 will give you root 2, and from the question it said, where you see root 2, you make it a. So our answer is a. Now let's go to the second question. The second question says 8 over root 2. A student can jump on this and just say you have your answer as 8 over a, because root 2 is a. This is not the right way to solve this question. Before you can replace root 2 with a, you have to first rationalize. So when rationalizing, you can say 8 over root 2, then we rationalize by multiplying both the numerator, that's 8, and the denominator by root 2. So we have times root 2 times root 2. Going back to the numerator, you have 8 times root 2 as 8 root 2 over, like done in multiplication of surds, root 2 times root 2 will give you 2, because root 2 times root 2 is root 4, and square root of 4 is 2. We've not finished, we can still cut. You can see 2 into 1, 2 in 8, 4. Now we have this as 4 root 2 over 1, which is the same thing as 4 root 2. And from the question, it says where you see root 2, you replace it with a. And this is like saying 4 times root 2. 4 root 2 is 4 times root 2. So we can say this is 4 times a, since root 2 is a. So our final answer is therefore 4a. That's 4 times a is 4a. And it's not 8 over a. It is not 8 over a.